Okay guys, this is going to be a very short video because you're going to do a little at-home lab today. So that's going to be exciting. We're going to be on page 80 of your notes. And I wanted to tell you guys thanks for watching the videos and doing the assignment last time. I saw a lot of you guys did that and you asked some really good questions. So that's awesome. I'm going to just respond to like 2 or 3 of those questions that people asked that a lot of people had, and I thought were really good. You guys all deserve stickers for asking good questions, but of course I can't give them to you. But like, here's what I would give to you if you were in class. So, a lot of people were a little bit confused about how covalent compounds dissolve and whether or not they actually do dissolve. They do dissolve. And what it looks like is they just kind of mix around with the water. So it starts out and the sugar molecules are just all close together. And then as they dissolve, they just kind of separate and they're just mixed around with the water. So yes, covalent compounds do dissolve. The only difference between covalent and ionic is that ionic will break into ions, into positive and negative charges, but the covalent compounds don't. They just mix around with the water. But they do dissolve. Somebody was wondering how table salt can dissolve if it's got a metal in it. Table salt does have sodium in it, which is a metal, but it's a metal ion. It's Na+. So if it had pure sodium metal, then it wouldn't be able to dissolve. But since it's sodium ion, it can dissolve. And then finally, somebody was asking about pool water. They were wondering if pool water can conduct electricity because it just has chlorine in it. And chlorine isn't ionic, and that's true. But pool water has a bunch of other things in it too besides chlorine. Like it has some salts and minerals in it that are ionic. The only place you really find pure water is in a lab, like pure distilled water. Almost all water that you buy at the store, that you find in a swimming pool, is going to have some ionic compounds dissolved in it. So pretty much all water that you encounter will conduct electricity. Okay, now to the new stuff for today before you do the lab. There's a phrase that you want to be familiar with, and that phrase is like dissolves like. And this phrase has to do with what types of compounds will dissolve in other types of compounds. And what it means is that compounds with charges will dissolve in other compounds with charges. So compounds that have charges are things like ionic compounds and polar compounds. Those dissolve really well. Compounds without charges will dissolve with other compounds that don't have charges. So we're going to make a little table and we're going to kind of chart out what types of compounds dissolve in other types of compounds. So our table is going to look like this. We're going to have types of compounds, and then we're going to have a column that says solution formed. And what I mean by that is, do they dissolve in each other or not? And then we're going to have an example. No question mark there though. Sorry about that. Okay. So first of all, we're going to talk about if we mix 2 polar compounds. So a lot of you guys probably already know if I mix 2 polar compounds, they're going to dissolve in each other because they both have charges, they're attracted to each other, so they're going to dissolve. So we're going to say yes. An example of that would be water, which hopefully you all know is polar, and say hydrogen peroxide. You probably at your house have some hydrogen peroxide and it's already dissolved in water. It's not pure hydrogen peroxide. Okay, let's talk about polar and ionic. So polar molecules have charges, ionic molecules have charges. So yes, they're going to dissolve. An example of that would be something like water and calcium chloride, which is CaCl2. Table salt is also ionic, you might remember. Let's now talk about non-polar compounds. So there's actually two types of covalent compounds. We've got polar covalent, so actually under all these polar ones, we should probably write covalent. So we know that those are covalent. So let's say we have two non-polar compounds. So let's say we have non-polar covalent and non-polar covalent. Okay, neither of those have charges. That means that they are going to dissolve each other. They are similar. These types of compounds are alike. So an example of that would be maybe oil, which is a common non-polar compound that we talk about. And another non-polar compound is gasoline. I don't want any of you to go trying to mix oil and gasoline. That's probably not a good idea, but they would dissolve in each other if you mix them. Two more we're going to do. What if we try and mix polar covalent and non-polar covalent? You probably know that those are not going to mix. We're not going to form a solution. And our classic example of that would be water and oil. Okay, now our last combination is non-polar covalent and ionic. So think about it for a second. Do you think these guys are going to mix? The answer is no, because ionic has charges and non-polar does not have charges. So basically, non-polar is not attractive enough for ionic compounds. So those are not going to dissolve. So that would be if you tried to dissolve oil and calcium chloride, which is rock salt. If you tried to take some rock salt and dissolve it in oil, that wouldn't work. Okay, so that's pretty much all of the information that you need to be able to do the lab now. In case it's not clear, you might not need to write this down because it might be clear to you, but you guys should understand that water is a polar molecule and oil is a non-polar molecule. So water has a positive side and a negative side. Oil does not have a positive side or a negative side. These are both covalent. This one's polar, this one's non-polar. So just make sure you know that. And I hope you have a good time with the lab today. Have a great day.